Alright, we're looking at lines in the coordinate plane today. We're going to talk about the slopes of parallel and perpendicular lines. Parallel lines have the same slope. They have the same rise over run, the same rate of change, which allows them to be parallel to each other. They're always increasing or decreasing at the same rate. So when you look at an equation, notice these are in slope-intercept form, y equals mx plus b. The slope is 5. This equation has the exact same slope. So even though I haven't seen the graph of these two lines, because they have the same slope, I know those lines are going to be parallel to each other. Now, perpendicular lines are lines that intersect to form right angles. So any angle that they are forming is going to be a right angle. Now their slopes are opposite reciprocals of each other. A reciprocal is when you flip a fraction. So if I have 2/3, a reciprocal would be 3/2. Now the positive or negative will be opposite though. So these are not opposite reciprocals of each other. These are just reciprocals. For them to be opposite reciprocals of each other, if this one was positive, this one would need to be negative, or vice versa. So you will always have one positive and one negative, and they'll be reciprocals of each other. So when I check these two equations, the slope here is 2 and a negative 1/2. Those are opposite reciprocals. Now when you have a whole number, in case you're not seeing the reciprocal here, when you have a whole number, if you wanted to make it into a fraction, you would just put it over 1. So if you want to do the reciprocal, it would then become 1/2, and we change the positive or negative to make that one negative. Here we have a slope of -5 and a slope of a positive 1/5. Again, those are opposite reciprocals. So even though I have not seen these graphed yet, I know that they will intersect and they will be forming right angles where they intersect. They will be perpendicular lines. Now, if the slopes are not congruent, if they're not the same, and if they are not opposite reciprocals, then those lines have to intersect, but they will not be perpendicular. So they're just intersecting, but they're not perpendicular or parallel. Alright, so on example 1 it says determine whether the lines are parallel, just intersecting, or are perpendicular. So I'm just going to look at their slopes. This is in slope-intercept form, y equals mx plus b. So the slope here is 2. Same thing on the next equation, slope-intercept form. When I compare their slopes, they have the exact same slope. So I know that these lines are going to be parallel to each other. Okay, same directions on number 2. Determine whether the lines are parallel, just intersecting, or are perpendicular. This is in slope-intercept form, so the slope is 1/3. Now this is not in slope-intercept form. This is in point-slope form. Y minus y1 equals m times x minus x1. So the slope in point-slope form is found right here, and this slope is -3. Well, when I compare those are opposite reciprocals. If I were to flip this fraction, it would become 3/1, which we just say is 3. It's a whole number. And because one is positive and one is negative, those are opposite reciprocals. I know these lines are perpendicular. Okay, same thing on example 3. Now, the more difficult thing on example 3, however, is that these equations are currently in standard form. ax plus by equals c. So what I need to do is I need to turn them into slope-intercept form so that I can see what the slope is. So I want them to be in this format, y equals mx plus b. So I'm taking this first one, put it in the slope-intercept form. First thing I got to do, get the x over here. So if I subtract 3x minus 3x is 0, it's gone. If I do it on one side, I got to do it on the other side. Remember that these are not like terms. So I have a -3x and a positive 7. And I still need to get y by itself, and to do that I got to get rid of the 2. So I'm going to divide by 2. If I do it on one side, I got to do it on the other side. Make sure everything is divided by 2. Now 2 does not go evenly into a -3. So I'm just going to leave it as -3/2x, and then 7/2. Again, 2 does not go into 7 evenly. So I got it in slope-intercept form, and the whole point of doing that was to identify the slope. The slope is negative 3 over 2. Now I need to do the same process with the other equation, because I can't compare their slopes until I have both slopes. Same thing. I want to get it in slope-intercept form. So I want that y all by itself. So I start by getting rid of the x. Make sure you don't forget this sign when you bring this down. So I have a negative 4x and a negative 7. And then I need to divide by negative 3. Y is being multiplied by negative 3, so I divide by negative 3. Make sure everything is divided by negative 3. So right here, a negative divided by negative is positive, but 3 does not go into 4 evenly, so it stays like that. Same situation over here. Negative divided by negative is positive, but 3 does not go into 7 evenly. Y equals mx plus b. So the slope here is 4/3. So when I compare the slopes, they're not the same, so it's not parallel lines, and they're not opposite reciprocals, so they're not perpendicular. So I would say that these are just intersecting. Alright, on example 4, it says graph the pair of lines, give the slope of each line, and use the slopes to determine the lines are parallel, perpendicular, or neither. Alright, now I could find the slopes of the lines by doing the slope formula, but I got a graph here, so let's just plot the points. I want line AB, so I got the point 0, 3, and the point 1, 1. So here is one line right here. And I could get the slope of line AB by just counting the rise and run. So to get from this point to this point, I have to go down 2 over 1. When you go down 2, that's a negative. And then over 1, negative 2 divided by 1 is just a negative 2. So there's the slope for line AB. Now I need to do the same thing for line CD. So point C is at the point 1, 2, 3, 1, 2. There's C. And the point D is at 5, 3. 1, 2, 3, 4, 5. 1, 2, 3. And there's point D. So if I connect these 2 points, that will give me that line. And I want the slope of that line, so again I'm going to count the rise and run. From here to here I go up 1 over 2. Rise over run. So now I have my 2 slopes to compare. I got negative 2 and I got positive 1/2. Those are opposite reciprocals of each other, so I know that these lines are perpendicular. Alright, last thing we're going to do is example 5, and this is going to combine pretty much everything we learned about in 11.3 and 11.4. It says find the equation of the perpendicular bisector for the hypotenuse of the right triangle below. So here's a right triangle. This is your right angle right here, because a vertical line and a horizontal line are going to be perpendicular to each other. So that means this is the hypotenuse. We want the equation of the perpendicular bisector of that hypotenuse. Okay, for it to bisect it, it's got to go through its midpoint. So the first thing we're going to do, find the midpoint of the hypotenuse. Now I could get the coordinates of both endpoints and plug it in the midpoint formula. Or I could just figure out where is exactly halfway across. To get from here to here, I got to go up 1, 2, 3, 4, over 1, 2, 3, 4, 5, 6. 4, 6. I only want to travel half of that different distance. So half of 4 and 6 would be 2 and 3. Half of 4 is 2. Half of 6 is 3. So I go up 2 over 3. And right there, that's the midpoint of the hypotenuse. And that is at the coordinates 1, 2, 3, 1, 2. So I have the midpoint at the coordinates 3, 2. Then we also want the slope of the hypotenuse. Remember, for slope, we can just count rise over run. So from here to here, I go up 2 over 1, 2, 3. Rise over run, 2 over 3. So the slope of the hypotenuse is 2/3. Well, now I should be able to get the equation of a line, because now I know a point that that line goes through. And because I know the slope of the hypotenuse, I should be able to find the slope of the perpendicular bisector. Because remember, if they are perpendicular to each other, their slopes are opposite reciprocals. So the slope of the perpendicular bisector, I flipped the fraction, and because this one was positive, I changed this one to negative. So now I have a slope and a point for the line that I want an equation for. So I'm going to start with point slope form. So I have the slope that goes in for m, and I have a point. And remember, this is your x1, y1. So the y1 is 2, and the x1 is 3. So as soon as I plug those in, I have an equation in point-slope form. Now I want that equation in slope-intercept form, so I'm going to distribute negative 3 over 2 times x, and negative 3 over 2 times negative 3, which gives me a positive 9 over 2. Now I want to subtract, or I want to get rid of this 2, and it's being subtracted, so I need to add it. So I'm going to add 2. And 9 over 2 plus 2 is 13 over 2. So there's our equation in slope-intercept form. And then the last thing we need is in standard form. So I need to get this in the form ax plus by equals c. So the first step is to move the x over. Because it's being subtracted, I need to do the opposite and add it. So now that's gone. And then I have it in the proper order, but I need it to be all whole numbers. So I'm going to multiply everything by 2. So 2 times 3 over 2 would be 3x, 2 times y, and then 2 times 13 over 2 is 13. And there's our equation in standard form. So we just combined everything we've learned in the last couple lessons into one problem.